Yay, another related rates question. Here we have a balloon leaves the ground 500 feet away from an observer and it goes up vertically at a rate of 140 feet per minute. And we would like to know at what rate is the angle of inclination of the observer's line of sight increasing at the instant when the balloon is exactly 500 feet above the observer's eyes. So, as always, let's draw two pictures to illustrate the situation. First of all, we have this person right here, and his eyes is right here, right? And then 500 feet away, that's the balloon, so I'm just going to put like this down, and this distance is always going to be 500, so let me just put that down. And then of course you have the balloon that's going up, so let me just first draw the balloon right here, and I will just label this part as the part that the balloon is going up. Well, we also want to keep track of the angle, so I'll just call this angle theta. Of course, from the eye directly to the balloon is the line of the sight, right? Okay, so this is pretty much the picture. Now, as the balloon goes up and up, we will have another picture. So here is the person again, and then this distance is still 500, and now the balloon is higher right here, and I'm gonna just put this down right here. And of course we can label some variables if you like. You can use y because it's vertical, you can use h because it's the height maybe. I think I'll just use h. So h is changing, so that's why it's in red. This distance is always 500, so let's put that down. And even though this distance is also changing, but we don't really care because the question is only asking us to build up a connection between h and the theta. And this is the picture at the instant when the balloon is 500 feet above the ground, meaning we want h to be 500, like this. Okay, now let's go back to this, and let's just look for the information. 500 is labeled already, and it says the balloon is going up vertically at a rate of 140 feet per minute. Therefore, based on our picture and the variable, this is the h. So this right here tells us that dt is 140. So that's cool. And the question is asking us at what rate is the angle of the inclination changing, right? And the angle is getting bigger and bigger. So I'll just indicate that we want to know d theta dt is equal to what? And now let's look back to this picture. We have a right triangle, but this time I don't really care about this third side, this hypotenuse, right? Because we care about the opposite side and then the adjacent, and then also the angle right here. Opposite and adjacent, let's use tangent. From here, let me write down tangent theta is equal to h over 500. So let's put that down right here. And that's pretty much it. And we just have to remember theta and h, they are both functions of time. And right here, you can go ahead and differentiate this with respect to time. Or if you don't like the original tangent, you can actually take the inverse tangent on both sides. In fact, that's slightly easier in this situation. So let's do that. So let me just say theta is equal to the inverse tangent of this. H over 500, let me just put down 1 over 500 times h, like that. And then I will look at this and differentiate with respect to time. Because this way, on the left hand side, I get d theta dt right away. On the right hand side, the derivative of inverse tangent of something is first we put 1 over 1 plus, and put on a parentheses with this inside, right? So 1 over 500 times h. And then we square that. And then we do the chain rule. We multiply by the derivative of this inside. Derivative of 1 over 500 times h. You first put down 1 over 500 and the derivative of h, because h is a function of time. We do what? dh dt. So that's pretty much it, and we just have to plug in some numbers. We have d theta dt that's equal to 1 over 1 plus 1 over 500, and the h is nicely equal to 500. So just put that in right here, and then square that, and then we have another 1 over 500 like this, and the dh dt, it was given to be 140, so we multiply by 140 right here. And then from all this, you can just work this out. This is just this computation right here. Just work everything out, and depending if you like fraction or you like decimal. If you like fraction, it's 7 over 50. Right? If you like fraction, it's going to be 7 over 50. Or if you like decimal, I'll also put that down. This is 0.14. So up to you. Anyway, I will go with decimal, and this is the theta. Theta is the angle, so I will put down radians per, the time unit was minute, so we just say radian per minute. I will box this right here for you guys. Right, so that's it.